Hey, I'm Chris Ralph, the professional prospector, and today we're going to be talking about prospecting for lead silver ores. Basically, lead and silver go together. A surprising amount of lead comes from silver mines, or silver comes from lead mines. A lot of silver mines produce significant lead as a byproduct, and a lot of lead mines produce significant lead as a byproduct. Let me show you a diagram that shows an example of this for even an ore that contains only 1% silver, and actually a lot of them contain a lot more than 1%. So let's take a look.
Now this diagram shows what you have when you have some galena, which is the main ore mineral of lead. In fact, it's virtually the exclusive ore mineral of lead. Probably way more than 95% of all lead comes from galena, which is a lead sulfide mineral. It's normally 13% sulfur, 86% lead, and then it has silver in it often. If it was silver free, then it would have 87% lead. But if you have 1% silver, and actually a lot of silver lead ore, a lot of galena has more than 1%, or not a lot, but maybe 1 to 5% is fairly normal. If it's only 1%, you would see the revenue that would come from that on the right there, that the lead would only be 19% of the value, and the 1% silver, because silver of course is so much more valuable, would be actually 81% of the value. And that's why I'm talking about this as prospecting for lead silver, even though actually silver is often the higher percentage of the value.
Now, lead is a lustrous blue-white colored metal that slowly tarnishes and turns gray in the air. When it's fresh though, on a fresh surface, it's a bright, shiny blue-white kind of color. But over time, it turns gray. And it's not considered super rare. The Earth is actually about 1/1000th of 1% lead, which means that about 10 parts per million is the average lead content of the soil. And so it's not really considered super rare, and there are natural geologic processes that tend to concentrate the lead into ores that we can mine, and it's not hard to extract the lead from the ores. So, you know, there's a lot of lead that's, like I say, produced as a byproduct from silver mining and that sort of thing. So lead is not considered super rare. It once was used for a whole lot more things, but I kind of discussed how a lot of politicians somehow think that the average man shouldn't have lead, whether it's in the form of a diving weight or a wheel weight or a bullet. So let's take a look at prospecting, because lead silver ores really can be valuable. Now, one of the things about lead ores is it occurs in different kinds of formations. Some of them are kind of horizontal, and in Missouri they mine a lot of this type of ore called the Mississippi Valley type lead deposit. We'll talk a little bit more about that. But there are also a lot of vein type structures, replacement bodies and that kind of stuff. The replacement ores are a lot of times related to porphyries or other intrusive type bodies of rock, like granitic rocks. There are also a lot of epithermal type deposits, which are vein type deposits that are formed comparatively close to the surface. And those are like a lot of times the ones that are super rich in silver but have significant lead byproduct. One of the things that we want to talk about is how these things look if you should come across one in the field. You see, it's interesting to note that just the effect of rain and air and water on the ores at the surface will change them. Literally, the main ore mineral for lead, that by far the most common, is a mineral called galena. It's a lead sulfide. It's a combination of lead and sulfur. And it's about 13% sulfur, and the rest is lead and sometimes other metals like silver. This rock, or this mineral, is the chief ore of lead, by far and away the most important. But when it's exposed at the surface over long periods of time, the action of air and water on it will convert the sulfur in the mineral to sulfuric acid. And it'll convert the lead into other lead minerals like ceroside or anglesite, other things. We'll talk about those in a minute. But it also has a tendency to draw those minerals down from the surface. It's what happens. You'll get a kind of a low grade or super barren zone at the surface, whereas further down you may have much higher grades. Probably one of the most famous lead silver deposits on the entire planet is at Broken Hill in Australia. And this deposit on the surface, it was a kind of a gossamer iron oxide and manganese oxides. There wasn't a lot of good lead ore on the surface or good silver ore either. But by exploring it and getting further down in the deposit, miners found that even those barren or not very good grade surface materials gave way to super rich stuff further down. And that's what I want to point out to you, is that a lot of silver lead deposits are maybe near barren or very low grade at the surface, but deeper down they can be super rich. And it's because both the lead minerals and the silver minerals are leached from the surface, and they leach down into the vein and redeposit. Let's take a look at how this process of weathering and enrichment occurs.
Here's the diagram to illustrate how that works. You see the vein that goes through the country rock, and on the surface where it's exposed to water and to oxygen from the air, these react with the minerals and produce a leached zone on the surface. As the minerals are dissolved, they move down, and just above the water table you'll get rich oxidized ore. So you get minerals like cerosite, and then for silver, cerargyrite or native silver. And then below the water table you get rich sulfides, and it's basically the material from the leach zone is moved down. Eventually, below the rich sulfide zone, the sulfide enriched zone, you get the low-grade sulfide ore that reflects what the vein was originally, how it was deposited, what's actually there without modification from leaching and redepositing the valuable minerals.
So that's one thing you need to know, is that a whole lot of rich lead, silver type deposits have been found by discovering comparatively low grade materials at the surface, like Broken Hill. Now, Broken Hill, super famous, but by no means is that the only type of situation where that's occurred. No, it's pretty common actually. And so low grade deposits at the surface doesn't necessarily mean bad. It may be much better deeper down. And it's important as a prospector for you to know that kind of stuff. So let's take a look at some of the different minerals that lead forms into. And we're going to start with the oxidized lead minerals. These are the minerals that were originally galena or some mineral like that, and through the effect of air and water on the surface or near the surface, they've been transformed into other things. Let's take a look at those now.
The first mineral we're going to look at is cerosite, and you can see from this image here that it's white, usually light colored. It doesn't have to be snow white like this, but it's usually a light colored mineral. It's the carbonate of lead. It's produced by reacting carbonates with lead from galena. Here's another picture of it. You can see this is a more compact group, but it sometimes occurs in earthy types of formations. And here's another one that's a crystalline type of formation. But again, these are all forms of cerosite, and they're an important ore of lead. This is anglesite, which is another important ore of lead, another product of water acting on galena. And galena is lead sulfide. Well, this is lead sulfate. So basically it's just lead, sulfur, and oxygen from the air. Now you see these crystals are so nice that they're actually clear, And both anglesite and cerussite can occur in forms like this that are so clear that one could cut gemstones from them. But they're very soft, even though they do have beautiful optical properties that they get from the lead. This is an interesting specimen. You can see the light colored white and tan, and then the dark gray and stuff. This is an illustration that actual weathering can separate out minerals, because the white light colored material on the right is the lead mineral anglesite, the one that I just showed you the crystal of. This is a more earthy, more compact version. On the left, however, the dark colored is cerargyrite, a silver mineral. These were once both in the same specimen, and by the weathering they were separated because the galena contained both, but when they came out and were changed in the weathering and oxidation, they couldn't go together again, and so they had to separate. And so basically this was all one crystal, one bit of ore at once, and now it's two different ones. Now we're going to take a look at some more unusual ore minerals for lead. This is bindhemite. The bindhemite is actually both the yellow and the greenish colored material. It's an oxide of lead and antimony and forms from the oxidation of a less common lead mineral known as jamesonite. This is actually a sample from a mine that I worked at in Nevada, and I collected it. It's actually quite rich in both silver and gold, in addition to the lead and antimony. Here's another example of bindhemite, a more earthy, more porous version, but still the same thing, rich in silver and gold. This is boleite, an unusual lead, gold, copper mineral that's found in some desert areas and mines in Mexico and a few other places. This is crocoite, a beautiful lead chromate mineral that's valued really mostly for its mineral specimen qualities. It really is very brightly colored like this. The next couple of minerals that we'll look at will be minerals really valued mostly for their specimen qualities. This mineral is pyromorphite. It's a lead chlorophosphate. It's also a product of oxidation and makes for some really beautiful and valuable mineral specimens. Finally, this is wolfenite, a lead molybdate. It makes some really beautiful orange to yellow to red types of crystal clusters, and is considered quite valuable in a mineral specimen form, but it's not much of an ore. So that's our look at the oxidized lead minerals.
So that's kind of a survey of the oxidized lead minerals and some of the oxidized silver minerals that occur with them. And then let's now take a look at the primary, deeper down sulfide ores. This is what forms originally by processes in the earth as the heat and pressure of the earth and water working through the rocks creates these lead deposits. Let's take a look at the original sulfide minerals that form deep within the earth that are before they get oxidized, but that they haven't had the effects of air and water acting on them.
So this is a chunk of galena. It's the main and by far the most important ore of lead. It's this silvery gray color. It breaks into a cubic cleavage, but it also forms cubic crystals. So we'll take a closer look at that. Here's another specimen of galena ore, and you can see if you look really closely at this, the cubic breakage, basically three angles of breaking all at 90 degrees to each other. And one of the things about this is cleavage is just a natural break. The crystal, as it grows, just has a natural tendency to break along these planes. Here's another specimen of galena ore, and again you can see the breakage, the cleavage fragments along the thing. In some places on this ore, if you look really closely, you can kind of see that it almost makes like a book, but there are several planes of cleavage on this, and again it's a cubic type of plane. So if you find heavy gray material that looks like this with these breakage planes on it, you have a real high likelihood that the mineral you're looking at is galena. Now, Nevada was very famous in the 1800s for all the silver that it produced, and many of the silver mines were actually silver and lead mines. And you can see some examples of different galena ores from Nevada that were valuable mostly for their silver. Now, galena sometimes makes some really beautiful crystal specimens, as is shown here in this example. The white is calcite, the purple color is fluorite, and of course the dark gray is galena. This is a really spectacular specimen that grew in a pocket so that the crystal faces could grow unimpeded. Finally, this is jamesonite, a different mineral than galena. It's also a lead ore, but this is a lead and antimony ore. It's a lead antimony sulfide. And this is the mineral that when it weathers, it gives rise to bindhemite. It's the same color as galena and also heavy and clearly a sulfide, but you can see the lines on this that go vertically in this picture, the striations. That's very typical of jamesonite and something you won't commonly see with galena. So that's our little survey of lead sulfide minerals. There are a few other rare lead sulfides, but they're just so uncommon that I've chosen not to display these really rare sulfides in this video.
Now let's take a look at some of those different kinds of deposits. I mentioned the Mississippi Valley type. We're going to take a look at that. I mentioned also replacement bodies. We're going to take a look at some of those. And then also epithermal type gold, or actually a lot of them are gold, silver, lead ores. Let's take a look at some of those ores and the different geologic environments that they form in, because geologists will classify these different types of deposits, and it helps you understand them better so that you can prospect for them or look for them or understand them, is to understand the different bins or types that geologists will put them into. So we're going to take a look at the different types of lead deposits right now.
The first I want to look at is the Mississippi Valley type, named for mines in the Mississippi Valley of the United States. It basically is a type of ore body where limestones and dolomites, which are receptive to mineralization because they can be eaten apart by acids, are replaced by ores of lead and zinc. And this type of ore actually is the type that has the least amount of silver in it. They only have very small amounts of silver in these types of ores, but they can be good for both lead and zinc. As you can see from this map, these types of ores have been mined across a huge area in a number of different districts in the central and towards the eastern part of the United States. They have been quite productive, and mining still takes place in a number of these areas, especially in the tri-state area where Oklahoma and Arkansas, Missouri, and Nebraska come together. You can see from this worldwide map that the Mississippi Valley type ore deposit is prevalent all across the world, and it is a very large source of both lead and zinc in a number of areas and a number of countries. You can see that very many countries have at least some of these types of deposits. And as I mentioned, they're generally low in silver, so they're big producers of lead and zinc, but only very small producers of silver. Our next type is the polymetallic replacement type, and this type of lead ore is it also can contain zinc and also contain significant copper and often significant silver and sometimes even gold as well. That's why they call it polymetallic, because it has a lot of different kinds of metals. This is widespread across the U.S., especially the western U.S., where it occurs in a lot of areas associated with the porphyry deposits. And you can see from this diagram that there's the polymetallic replacements, but down in the lower left-hand corner you can see an area marked as a skarn, and that's an actual deposit that takes place in full contact with the igneous intrusive rock that's down in the lower left-hand side. Our next type is the skarn, which I just kind of mentioned. It actually occurs where you have susceptible rock like a limestone occurs and actually comes into physical contact with a body of magma that's been intruded up into the older rock. And that's kind of what you see here. As you see, the skarn is that kind of green color, and it's actually touching the pink of the intrusive porphyry stock. This map also shows where the relationship of the polymetallic replacement types that I just mentioned. You can see they're off a little further away. These both occur in the same relative geologic environment. Our next type of lead ore is the epithermal type, and these are closely related to, again, magma chambers or stocks that are intruded, as we were just talking about. But these happen close to the surface where meteoric water, just rainwater that's in the rocks, is caught up by the heat of the magma and driven up through faults and fissures and creates what's labeled on this diagram as an epithermal vein. These are actually the type of lead, silver, and zinc deposits that are the richest in silver. These can be really much more silver ore than lead ore, although they often contain significant lead as well. Perhaps the most famous example of an epithermal type deposit of silver and lead is the Comstock lode up at Virginia City in Nevada. It was one of the hugest producers of silver and gold that was found in the western U.S. They produced quite a bit, although for the most part of the time that this was mined in the 1800s, they really didn't even bother to recover the lead or the zinc. They just recovered the silver and gold and figured that was good enough. The last type I want to mention is what's called the volcanogenic massive sulfide. And I had mentioned this type in my discussion of copper ore sources because it actually is a source of both copper and zinc and lead. And basically these form on the bottom of the ocean in volcanic areas where seawater circulates through faults and breaks in the volcanic rock, and there's magma fairly close to the surface, and you get what's called a black smoker. You may have seen some of pictures of these because they have fantastic life forms around them because of the heat that they give off. But the black smoke is actually ore of various metals, including lead and zinc and copper and iron. And eventually that smoke, the precipitate, piles up and in time turns into an ore body, and that's what this is.
Well, as a part of this, of looking at the different types, let's talk about some of the different areas around the world where lead has been mined and where it currently is mined. You see, it used to be a big deal in the United States. We had many lead smelters, a lot of historic ones too. Let's take a look at where lead is mined and has been mined around the world.
So here is a list of leading countries that produce lead in order for the top 10 anyway. And you can see that China by far is in the lead, and that Australia and the United States are significant. Peru also. Mexico's pretty good, but then it drops off down. One of the things that you can't see, because I don't have the list of the countries after Ireland on number 10, is that there's a whole lot of countries that produce, smaller amounts than this, but still significant amounts of lead. Some of it comes from the Mississippi Valley type, some of it comes from polymetallic replacements or skarns or epithermal or even the volcanogenic massive sulfide. There's a lot of different countries that produce at least some lead in their country.
Having looked at a lot of those different places, let's now take a look at how lead is smelted. We used to have lots of smelters in the U.S., not so many of them now, but there still are a few, and of course there are many around the world. Basically, a lot of that stuff is done in places like China, where the environmental requirements are not so strict. And in fact, you don't want to live close to a lead smelter unless they have really strict controls. because if you play loose and fast with environmental regulations around a lead smelter, then yeah, there can definitely be some environmental hazards. So let's take a look at the process of how it's done, how they turn these lead ores into lead metal that's used in, modern processes that lead is still used for, which, the biggest use of lead today is in car batteries. It still is a very big use of lead car batteries.
As I mentioned, we used to have quite a few little lead smelters around the country like this. In the mid to late 1800s, there were probably more than 100 lead smelters across the United States working on various lead silver ores, and they produced a lot of nice lead and valuable material like this. The modern process that's used today for treating lead ores and concentrates is, of course, it first has to be concentrated. The ore is crushed and it's separated, usually by flotation, out to where it can be purified, and then the purified concentrates are fed into the top of a blast furnace, as I've shown here. The lead and ore comes in at the top together with coke, which is a product of treating coal, and together they are heated and heated to really high temperatures to the point where any zinc that's in with the lead comes off as a vapor and is condensed, as shown on the right hand side of this diagram. The lead actually works its way down to the bottom of the blast furnace and collects in a collector, a tap hole at the bottom. Slag comes off the top of the lead, and then the lead, actual bullion, the metallic lead, is sent off to a refinery where the silver is separated out of it.
Well, I hope you've enjoyed this series on lead, the 3 videos I did, the original video on making lead from scratch, the recycling lead video where I recycled a bunch of the bullets that I collected over the years from metal detecting for gold, and then this video about prospecting for lead and lead silver ores. And I hope you've taken that and you've enjoyed it and it's been productive for you. Next, I'm going to do a series on aluminum. And that's going to kind of be, I did a series on copper. If you want to look at some of my older videos, you can take a look at that. If you are interested in the other videos in this lead series, I think you might enjoy them. And the next, we're going to take a look at aluminum. We're going to look at recycling aluminum, because I'm not going to try to make aluminum. Making aluminum is a very active metal, and making aluminum from scratch is pretty difficult. But we'll talk about how aluminum is made. So hang in there, and the next videos will be about aluminum. I hope you enjoy them. But most of my videos are about prospecting for gold and finding gold nuggets, metal detecting, as I mentioned, but also sluicing and dry washing and other methods of collecting your own gold. And it's really fun. I really enjoy it. And if you're interested in finding gold for yourself, because gold is out there to be found, there's widespread small amounts of gold. And if you know what you're doing and you have the skill as a prospector to find it, there are larger amounts of gold out there to be found. There really are. So if you are interested in that, I wrote a book about it, and I'm going to tell you a little bit more about my book right now. So let me tell you a little bit more about my book. It's called Fistful of Gold, and I wrote it because I want you to be able to go out and find for yourself Fistful of Gold. And you can see that it's an encyclopedia with all kinds of information, pictures, and that sort of thing. It's not in color, but color would have cost me a lot more to have printed, and so the book would have cost a lot more. It's for sale on Amazon, and you can pick it up. I'll put a link in the description below. I also serve as the editor for a prospecting magazine. It's ICMJ's Prospecting and Mining Journal. And honestly, you should check that out. We got stories and information, legal stuff, everything you know to increase your skills as a prospector. I write articles in this every month, and a lot of other very experienced prospectors contribute to the magazine as well. So check the magazine out. Also, I have a website, and the website is at NevadaOutbackGems.com. I'll put a link for it in the description below. But there's gobs of information there that you will find useful in your prospecting efforts. Finally, I want to say that I really appreciate your comments and thoughts and even positive criticism. Don't come on there and just toss out insults, because I'll just delete your comments. But if you've got helpful things to say and questions to ask, do write and put those in the comments, because I answer my comments to people, and you'll hear from me in responding to you. So if you've enjoyed this video and you like what you see and you're interested in finding out more, well then sign up, subscribe, and hit the notification bell so they'll let you know when I post new videos. And like it and share it if again you see stuff that you really are excited about. And I'll be coming out with lots more new videos, and so we'll see you again real soon.